Yeah, we've been talking about using the standard normal distribution and z-scores for finding probabilities, but there are other uses and several other uses of the standard normal distribution and z-scores. And really, again, the standard normal distribution is a big part of statistical analysis. So finding probabilities is not all it's about. And even with this example, there's more to it than even this example that I'm going to show you. But this is another use for the standard normal distribution. We can use a standard normal distribution to solve for an unknown, to find x. Let me go ahead and give you a scenario, and then we will work through the solution. A company requires all applicants to complete a qualification exam. Exam scores are normally distributed with a mean of 50 and a standard deviation of 10. Only applicants who score at the 85th percentile, the top 15% or higher, are interviewed and have a chance of being employed by the company. Applicants scoring below the 85th percentile are not considered for employment. The personnel manager needs to set the cutoff score for the exam. She will calculate this score using the standard normal distribution table and the z-score formula. But before we move on to the solution, let me talk about the applicability or the real worldness of this problem. There are companies that may have some type of qualifying exam. Maybe it's a version of the Wonderlic exam that applicants have to take, and they may have cutoff points based upon the performance on that particular exam. Maybe companies only take or consider the top 10%, top 15%, top 20%. If that's the case, then they would need to set that cutoff point. They know their mean for the exam. They know their standard deviation for the exam. But now they need to know the x value that's going to be the cutoff point. And that's what we're going to find for this particular example in the rest of this video. Now, because we're looking at the 85th percentile, we are interested in the top 15%. What is that score that separates the top 15 from the bottom 85%? To find that cutoff point, first of all, we look in the areas under the normal curve table, or the z-table. I've been calling it the z-table. It's also referred to as areas under the normal curve. We look in that table to find a value as close as possible to 0.350. The reason we're looking at 0.350 is because the normal curve is split into halves. One side is 0.5, the other side is 0.5. We find 0.35, subtract that from 0.5, then we have our 15% cutoff that we're looking for. Now we will be on the positive side of the distribution because we're above the mean. We're going to be looking for a cutoff point that's going to be above the mean. So let's go into the normal table, or the z-table, and find a z-score associated with an area of 0.3500. And we're not going to find this exactly. It's not going to be exact. But what we're going to do is look through our numbers, and I'm biased because I already know where it's at, but we're going to look, that's not going to work, that's not going to work. It's going to be, okay, here 0.34, 0.32, now we're getting closer, 0.37, okay, oh, there's 0.3508. Is there anything closer to 0.3500 than that? So we look at the scores in the immediate area. If there was a score closer, it's going to be right in this area. There's nothing closer. So 0.3508 is the value that we're going to use to solve this problem. Now we want the z-score that's associated with this value. Look to the left in the row and look up the column to the value in this row. We end up with a z-score of 1.04 that's associated with this area value of interest. Now we have everything we need to calculate the cutoff point for this qualifying exam. Let's go ahead and locate our z-score that we're working with on our normal curve. And this is the point on the normal curve that corresponds with our z-score. The area that we're working with is 0.3508. We add this to the 0.5 that representing the area below the mean, we end up with a value of 0.8508, or about 85% of the exam scores are below the mean. And that's perfect. What we're looking for is a top 15%. So this is going to be a good cutoff point for us. I mean, above the mean is a little less than 15%, but that's okay. We'll go ahead and round to 0.85 here and 0.15 here, and the score associated with a z-score of 1.04 is going to make a good cutoff that will meet the needs of the hiring manager that wants to separate the top 15% of applicants from the bottom 85% of applicants. So, to do this, we're going to use, to find the score, we're going to use the z-score formula, and we're going to plug in the known values to find x. We have the z of 1.04, we have the standard deviation of 10, and we have the mean of 50. We have everything we need to solve for x. First thing we're going to do to solve for x is multiply both sides by 10, both sides of the equation by 10. On the right side of the equal sign, or the right side of the equation, the 10 is going to cancel out, and we're going to end up on the left side with 10 times 1.04. The equation will be 10 times 1.04 equals x minus 50. But we still don't have x isolated. We need to get x isolated, so x by itself is on one side of the equation. To do that, we add 50 to both sides. Add 50 to both sides of the equation. That makes it disappear on the right side of the equal sign. On the left side of the equal sign, we end up with 10 times 1.04 plus 50 equals x. Now we just do this multiplication and addition, and we have the cutoff score that we're looking for. The cutoff score that will separate the top 15% of applicants from the bottom 85% of applicants is 60.4 on this exam. All right, that's just a quick example of another way that we can use the standard normal distribution and z-scores in our business analyses.